Okay, I think we can get started. Hi, everyone. Thank you so much for joining us today for this feature resource showcase, especially as it's so late in the day. It's really great to see so many people here. My name is Anna. I'm Planetary Science Education Assistant at the Geological Society, and I'm joined by Ashley and Sarah, who are part of the Education Department too. So this is going to be a very informal session in which I talk through the new planetary science resources that we are going to launch soon. And there will be an opportunity for questions at the end. I'm going to share my screen a few times. Please do let me know if you want something to stay on the screen for longer, because I'm going to be switching screens quite a bit. Just a quick logistic note, this meeting is being recorded. So if you do not want to appear on the recording, please keep your cameras off. And feel free to use the chat for questions at any time, but we'll get to them towards the end. Okay, so broadly speaking, there will be two new resources that we are going to release. First of all, there will be a sample box, which is going to be available for teachers and educators to borrow, with suggested lessons to run using our samples. And secondly, an educational game to do with planetary defense, saving the Earth from incoming asteroids. So I'm going to spend most of the session talking about the sample box, a little bit at the end on the game. The resources are for pupils studying science and a little bit geography, but mostly science at Key Stage 2. Specifically, we'll be looking at the space topic in Year 5. There are a few other curriculum links though. I will emphasize those as we go along. These resources are part of a new project which we have running this year called Project Orbit. So Project Orbit is funded by the UK Space Agency as part of their Space for All Fund, which aims to make planetary science, planetary geology more accessible to school pupils and the general public. We aim to develop a sustainable strategy to integrate planetary geoscience into our initiative, to ultimately encourage uptake of planetary science at university level and through careers. But really, when we talk about Key Stage 2 resources, we just aim to inspire, use the exciting context of space to inspire interest in science, STEM subjects in general. Okay, so the sample box is going to contain a number of different things. It looks like this. We're going to make it a bit more travel friendly. And I just heard something rattle. But yeah, I'm going to go through what it contains, and then I'm going to go through the various associated resources, so lesson plans and so on. So if you just give me a second so I can share my screen. Okay, then anyone be able to confirm that you can see my screen, please? I didn't hear no. Okay, so this is what the sample box looks like in more details. And this is an annotated image of what it contains. So there are meteorite samples, total, I believe there are 9 meteorites, as well as some earth rocks, which look like meteorites. So you can probably see where this is going. We're going to get, there's a little game to find the differences between earth rocks and meteorites. There are also impact rocks, that is rocks that are modified or generated by impacts between meteorites and the Earth. It will also contain 3D models of impact craters, which will become relevant when I talk about the lessons. We're also going to include some geosoc badges and also hand lenses for the pupils to look at the rocks up close. There will also be a USB stick with the various lessons and everything else involved. So with the meteorites, there is at least one of each main type of meteorite. Each meteorite is unique, so that is to say there is one specimen of each. Some of them are in car trays, so the usual white trays that will come in, and some of them are in boxes, which are for display only. The boxes are not meant to be opened because the meteorites are either too small or too fragile. And as we know, sample handling by children is a destructive analysis. So some of them are in boxes because they are not supposed to be opened. One thing to emphasize, all of these are real meteorites. They have come from space. The children don't believe me when I say it, but it is true. So hopefully, if nothing else, is going to get them excited about space. We then have some Earth rocks, as I said, which look like meteorites. We call them meteorons. Sorry. We've got some samples of basalt, anorthosite, hematite, breccia, and also these two little vials which contain regular simulant, basically sediment which looks like the sediment that you find on the moon and on Mars, but isn't. It's obviously made on Earth. But we've got these little vials, which are part of a lesson as well. Okay, the impact rocks. So these, again, rocks modified or created by a meteorite impact. We have 5 of them, 1 of each. And they are impact glasses and rocks that have been partially molten because of the heat and strength of an impact. And finally, we've got these 3D printed crater models. So the models are of craters from the moon, Mars, and 1 from the Earth. And these models are also accompanied by guidance for tactile users. So if you have any pupils who are visually impaired, hopefully they can make full use of these resources as well. And that is it on contents. And by that, of course, I mean physical contents. There are all the lessons and so on left. One thing to mention, we are currently in the process of checking the 3D models and the guidance with tactile users. So this part of the box may be subject to change a little bit, but we'll be final by the time we roll out the boxes, of course. Okay, so now that I've told you all the random rocks in these boxes, I'm going to tell you how we envisage them being used. But the quick answer here is you can incorporate them in any lessons and any teaching that you already do. So I can imagine them being incorporated really well in, year 3 rocks, for example, even if you don't run a full lesson about it, you just show them some Earth rocks, some space rocks. I'm sure that will be exciting for them. But if you wanted to run our lessons, we will provide lesson plans, PowerPoints, and handouts for the children. So I'm just going to go through the lessons in summary. I don't think I would have time to go through them in detail, but I'll go through each lesson and outline what the lesson is, what the curriculum links are, and also just a very brief summary of how we would expect the lesson to go. So the first lesson is just an introduction to meteorite, where they are, what they are, where they come from, how they form, that sort of thing, and how to identify them. The lesson is linked to the science curriculum, specifically the Earth and Space module in Year 5, properties and changes in material in Year 5, and also working scientifically, as the lesson contains an exercise that gets pupils to make observations about rocks and draw conclusions. There is also a link to rocks in Year 3. However, as most links are in Year 5, we place this lesson in Upper Key Stage 2. You absolutely, as I said, could bring out some space rocks in Year 3. And I'm sure they would enjoy that. So the lessons start by discussing terminology. So what is a meteorite? What's a meteor? What's an asteroid? Different words that we use to describe space rocks. We then introduce a very basic meteorite classification. And in the middle of the lesson, there is an activity to hunt for meteorites. I've just realized I'm not currently sharing my screen, so let me just fix that. Bear with me for 1 second. Okay, introduction to meteorites. So, as I said, what's a rock? Terminology. I'm aware I'm not showing my screen. That's because I'm not intending to go through all the presentation. I'm just showing you the highlights. classification for meteorites, and then looking at some meteorites, making basic observations. This is where the handout comes in. So we're providing this handout, which is basically a table for them to write observations in. You're welcome to use that if you find it helpful. After the observations, there is a checklist for meteorites that we provide again. So these, if the answer is yes to these questions, a rock is usually a meteorite. And hopefully, hopefully this is an easy exercise. We ran it last week with Key Stage 3 pupils, and they all got it right. So hopefully this is going to be fine. But if they are struggling, maybe tell them that there will be 3 meteorites as part of the 6 rocks. That usually helps. Okay, after that, we go through the answers. So there are 6 rock stations. 3 of them have meteorites, 3 of them have earth rocks. And for each of them, we give you the checklist. So how many of the points, how many of the questions have yeses, and is it a meteorite or not? After that, you could run an optional part about meteorite craters, or you could run the entire second lesson, which is about impact craters. So that's what the second lesson is about. The second lesson, yeah, so introduction to impact cratering, learning what a crater looks like, how it forms, then looking at some rocks that have been impacted to see what an impact does to rocks. For the curriculum links, again, strong links to the science curriculum through Earth and space, also forces through gravity, basically. Properties and changes in material, all of them in year 5. Working scientifically crops up again because they are looking at rocks and drawing observations. Sorry, making observations, drawing conclusions. Apologies, I'm trying to find the other lesson. There it is. Great. So yeah, introduction to craters. What happens when a meteorite hits, forms a crater? These are the usual elements the craters have. So this is where you give them the 3D models of craters so they can also feel what they feel like. Sometimes with craters, you can't quite tell how deep they are and that sort of thing. So it's helpful for them to actually be able to feel it. They can also sketch a crater and label their features, again, linking to working scientifically. There is a brief explanation on how craters form and then what happens to the rocks. And there's a similar exercise in making observations on rocks as before, and there is a handout for them to write observations in. And then slides for all of the rocks and just brief descriptions of them. By the way, something that will be included in the boxes will be for teacher use only these sample fact sheets. So with a bit more detail on each rock. So what they actually are, where they came from, if you're interested, the names of the meteorites and so on. So those are entirely for reference and probably more applicable to later key stages, but that will be included as well as a glossary. So, you know, that's not exactly a common rock name. So all of these words will be explained. Trying to make this as accessible and widely used as we can. That is lesson number 2. And lesson number 3 changes gears just a little bit. So in lesson number 3, we'll be looking at building moon bases in a minute. Yeah, so how to build a moon base. So this lesson is once again relevant to Earth and space, properties and changes in material in year 5 science, working scientifically as well. There is an added link to geography. I'm not sure if there are any geography teachers among us, but there will be discussion of natural resources, including energy, minerals, and water. So that could be a link to geography as well. So that lesson will start with a brief introduction to the history of lunar exploration and how right now there are several space agencies thinking about building permanent moon bases. So we will just get the pupils to think about what is necessary for a semi-permanent moon base. When you think about power, that is electricity, location, and how to build it. And hopefully it will get them to think about what sources of power could be available on the moon, where they can build, the source of power is solar power, where they can build a moon base as an extension, so where there is the most sun. And hopefully this helpful video will tell them where there is the most sun. This is definitely not going to play now. Oh no. Huh. Yeah, sorry about that. Yeah, they're going to figure out where there is the most sunshine, and then they're going to figure out how to build the moon. So how to build a moon base. So they'll think about various materials that we use on Earth for building and what could be accessible on the moon, just rocks. And then they'll do a little exercise on figuring out what rocks are best. So again, making the usual observations and then just thinking about what they would like to build with. It turns out that the best thing to build with is actually the sediment that I mentioned earlier. We can turn this into bricks. Yeah, through this cool idea of moon 3D printing. But yeah, that's basically it. It's the lesson ends with an outlook on lunar exploration. I think it might interest them to know that things like international research, like lunar research stations are planned for the 2030s. So maybe they could work on that research station if they choose to become planetary scientists. Who knows? But yeah, those are the lessons. As I said, along with the lessons, there will be a PowerPoint presentation and handouts, which you may choose to use. And also in the box in general, there will be a glossary of terms and a sample list. So a sample list going, there are 3 pieces of basalt, 3 pieces of anorthosite, 1 piece of this type of meteorite, and so on. There will also be an annotated image of the sample box, like the one I showed at the very beginning. Yeah, I think that is it on the contents of the box. So I'm now going to go a little bit into the logistics of how the box is going to work. So we will have 3 boxes available for loan. They will be available for loan for free by teachers and educators. We will roll them out in the new academic year, so hopefully from September onwards. We expect there will be quite a bit of interest, and because we only have 3 boxes, there will probably be a waiting list. So please watch our website for information on that. Initially, the boxes will be available for school teachers only to loan for up to 12 weeks at a time. So we'll essentially do a window at the start of term for you to pick up the boxes. They'll have to be picked up from our office in London. Apologies if that's causing logistical issues for you. The boxes have quite a few fragile rocks, so in the beginning we won't have capacity to post them out. So we will ask for you to come and pick them up and drop them off when you're done with them at the end of term, presumably. We aim to make the boxes available to home educators and students doing outreach as well. However, that won't happen in the first instance. So we will run a trial period, probably around a year, in which we will only loan this out to school teachers. And then following that, if all goes well, we will make them available to home educators too. Again, apologies. I know there are a lot of home educators on the call today. We really aim to make this available for you too. It's just we need to work out the logistics of a sample box borrowing at first. Finally, The boxes and lesson packages will be free to loan. However, we will ask you to sign an agreement which essentially makes you liable for the cost of any rocks that go missing or are damaged to a point where they can no longer be used. We understand that these will be handled by children and therefore reasonable wear and tear is expected. But if a rock returns to us as a powder, that would not be great. That is it on logistics. I can see a few questions in the chat. We will answer these in just a minute. I just wanted to sorry, I got distracted by the chat. Yes, the slides with the box will be available. Okay, I'm just going to quickly go through the darts. The game that I mentioned at the start. So this is purely an online resource, so nothing complicated like borrowing a box. Essentially, yeah, it feels like ages ago that I actually mentioned the game, but yeah, it's an educational game. It's about planetary defense, so getting people to defend the Earth against incoming asteroids. You will need, the game works by essentially throwing magnetic darts at a whiteboard. And this is all very abstract, so I'm going to share my screen again. Okay, yeah, so this is an educational game in which the pupils basically throw magnetic darts at a whiteboard. This is a whiteboard flip chart that we got for this. And they will hopefully they won't just throw the darts, they will also learn something, although we have run it before where they were just battering the whiteboard with darts and weren't really learning anything. So you really have to hammer the point home that this is that actually is something to learn here. But yeah, once again, we're linking to Key Stage, to Science. We think this game is suitable for Key Stage 1 pupils as well because it's quite an easy game. However, I don't believe there is a curriculum link, so you'd just be running it for fun, I think. So, you are going to need you're going to need a magnetic whiteboard. Most whiteboards are magnetic, so you don't need to worry about that. We will provide a file with the asteroids that you need to print. You are going to need to source magnetic darts. They are pretty cheap, found online. And you also need whiteboard pens and little magnets to attach the asteroids. There's some information on setup here. And the way the game works is, yeah, I won't go through all of this, but you've got all the information here. Sorry. Got all the information here and a bit of background on planetary science that might be helpful. And the idea is that they hit the largest asteroids, which are the most likely to hit the Earth. So you set it up by saying this is the highest likelihood of hitting the Earth. And the idea is that they will do a risk assessment, which, as we know, risk is sometimes quantified as likelihood of a hazard occurring multiplied by the impact or severity of the hazards. So likelihood of impact is this band, severity of the hazard is how large is the asteroid that's going to hit. And they'll hopefully figure out they need to hit the largest things in the red area. That's basically it. It is worth emphasizing then there is no imminent danger to the Earth from an asteroid. We don't want to scare them. This is just for fun. From our experience of running this exact game, they love it. This is going to go on our website very, very soon, probably a few weeks at most. And yeah, that is everything I've got. So I'm happy to take questions now. Ash and Sarah, if you could direct me to the questions that have not yet been answered, that would be really helpful.
Hello, can you hear me, Anna?
Yes, I can.
Perfect. So Jacob has asked if home educators, will they be able to get the STLs for the 3D printer?
The STLs, yes, I don't see why not. So all of these are open access on the NASA website, and we absolutely can include the files. Well, maybe not the files, but links to the files in any case. But yeah, that's a really good question, actually. Yeah, very easily done.
And Michelle has said, are the session resources available if you can't get the rocks in the box because you're not in London?
So all of the lesson plans and PowerPoints, etc., will go on the website. We are going to include a list of samples that you need. If you are able, like the lessons you can just download. Obviously, they all need samples. They are, we've designed them with samples in mind. If you could source your samples from, say, a local museum, or if your school just has a bunch of moon-like rocks, then you absolutely could run the lesson anyway. In the far future, we are looking to digitize the the samples as well, but as I say, far future. So please don't allow that. Yeah, perhaps we could include like really detailed photos of the samples. It's not the same as handling samples, but it will help. Any other questions? Oh, perfect. Yeah, local observatory is a good shout. The rocks aren't, they're not rare. We have bought them from the internet. So, we wouldn't ask you to buy your own meteorites, of course, but they're not particularly rare. So I think a local university or observatory, perhaps museum, should have them as well. Oh, thank you. It's great to see that people are interested. It's sort of been in the works for about 8 months now. Um, so it's been really exciting to be monologuing about it for half an hour. Brilliant. Well, if there are no more questions, we will circulate a link to a feedback form. That it's sort of a feedback / later questions form. So you can use it for either. That will hopefully be sent to the chat very soon, and I'm going to email it around as well. As for the recording of this presentation, I believe it's going to go on our YouTube channel, but I can drop everyone an email when that goes online, if you would like to revisit it. And the initial presentation that I sent, so the one showing you all the rocks, I will circulate that like tomorrow. Perfect. Thanks, Andrew. Okay. I guess if there are no more questions or comments, we can end it there. And I hope everyone had a fantastic evening.